In this video, we'll provide a brief overview of the Supermicro 1U server that supports 32 NVMe drives. These drives are EDSFF, but you can also use standard NVMe drives with an adapter or opt for EDSFF E1.S enterprise drives. This server is quite unique and hard to find. The entire front is occupied by the drives, with LED lights, a power button, and 2 USB ports located in the right corner. The case model number is 121NF-X11. Note that not all Supermicro servers with this model number support NVMe drives. It requires a specific backplane and special connection to the motherboard. Next, we'll take a look at the back of the system before examining the backplane and motherboard. Here's a view from the back of the system. On the left, you'll find 2 hot plug power supplies, followed by a remote management port, 2 10 gigabit network ports, a USB port, and an SVGA port for video output. The back of the system resembles any other Supermicro 1U server, with a couple of PCIe expansion ports, and nothing particularly unique otherwise. Now let's take a look at the backplane of this system, which is the most special part of this Supermicro server. We removed the front portion of the cover, revealing the backplane and the connections for the NVMe drives, showcasing the dense configuration at the front of this system. The backplane's part number is BPN-EDS3-121P, and it connects to the server via 8 data cables that link directly to the motherboard. Unfortunately, we haven't seen a similar system from Dell, HP, or Lenovo, despite the numerous applications for this type of setup. Now, let's remove the rest of the cover and examine the motherboard. We removed the rest of the front cover, allowing us to clearly see how the backplane connects to the motherboard, which has the part number X11 DSF-E. This system uses 8 fans to cool the NVMe drives, memory, and CPUs. Later in the video, you'll see that standard consumer NVMe drives will require additional cooling. There are 24 memory DIMMs, or 12 per CPU. The backplane, part number BPN-EDS3-121P, connects to the motherboard via 4 data cables on each side. Additionally, there are 2 orange-colored SATA DOM ports, where we will install a 256 GB SATA DOM and Windows Server 2022. This motherboard also features a USB connection and space for a micro SD card. We appreciate the layout of this motherboard as it provides all the necessary connections. Now, let's take a look at the parts we will be using. Now, let's take a look at the components we'll be installing in this system. We'll be using 2 Intel Xeon Platinum 8168 CPUs, which we really like for their 24 cores each, with a base clock of 2.7 GHz and a turbo speed of 3.7 GHz. For memory, we'll install 8 32 GB modules, totaling 256 GB. It's important to note that this system requires DDR4 ECC memory. In our case, we're using ECC registered memory. For testing, we'll use a basic Crucial NVMe drive with an adapter. Enterprise EDSFF drives are quite expensive, and we didn't have any in stock at the time of this video. There are many different adapters available on the market, ranging from very cheap to more expensive options, but we didn't have time to test them all. NVMe drives come in various types, including basic consumer drives, enterprise NVMe drives, and EDSFF enterprise drives. The largest drive we've seen on the market so far is a 6 TB EDSFF drive. We have installed all the components, including the NVMe drive, and will be performing some benchmarks on it. We've installed 256 GB of memory, with 4 memory modules per CPU, and there's plenty of space to add more. This motherboard supports up to 6 TB of memory. It's important to note that the TDP must not exceed 205 watts per CPU, which is the exact rating of the Intel Xeon Platinum 8168. Additionally, we've installed a 256 GB SATA DOM and Windows Server 2022 to conduct the benchmarks. The Windows installation on the 256 GB SATA DOM was successful. While we wouldn't necessarily recommend using a SATA DOM for your operating system in a production environment, our speed tests showed adequate performance without any slowdowns or overheating. We appreciate the space-saving aspect and the ability to use this drive in other Supermicro systems. The NVMe drive performed well initially, but started to slow down towards the end, likely due to heat issues. We recommend using enterprise drives or NVMe drives with pre-built heatsinks. The heatsinks should be thin to fit within the limited space. Overall, this is a great system, ideal for databases, virtualization, or any application requiring high I/O and substantial storage.
Built a